Okay, next, so we have a requirements as I did it in the previous video. Now we will work on the approach and strategy. Okay, so how can we know that we will use the which algorithm will we use? So when we read the information from the requirements, we can see we have two given as sorted in non-decreasing order. Yeah, yes, and we have to return an array. Num1 sorted non-decreasing order. What does it mean? It means we will use sort algorithm. So I just think about the brute force method. We just concat, I mean, pull on the two arrays into one, and then we will sort from this array. However, the time complexity should be n plus n log n plus n, while the requirements is only O n plus n. You see? So we will analyze why we use a specific algorithm. In this, one each is merge algorithm. So can we use the regular sort or another specific sort? Both we have used from the requirements, and both input arrays are non-decreasing order, so they are sorted already. So we don't need to sort them again. Yes. In this case, that we only merge them into one, it should be use merge sort. So what is the merge sort? Merge sort will break down array into many arrays. It is a divide and conquer. Let me check this one. Okay, spell it.
Divide and conquer.
Yeah, divide and conquer. Okay. Follow up the following the requirements. We have number one, number two arrays are sorted already, so we only need to merge them into one. So this method is really efficiently. Merge sort. It takes two already sorted subarray and merge them into one sorted array in linear time. Okay. It does by comparing the first element for each subarray and picking the smaller one, repeating the process until one subarray is sorted. Using the two-pointer approach from Cn, each elements from number 1 and number 2 is examined exactly once. Each comparison and placement takes constant time O1. Total steps should be O n plus n O n plus n. Okay, so let me explain more a little bit about the merge sort. Okay, for example, we have this one. That means it will break down, and break down, then it will merge one by one until end of this one. Okay, next. Okay, we have we know that we have to merge use merge sort, but we can use from the very beginning or from the backward. So if we use from the beginning of num1, so what we will do? We may replace the correct values of elements in num1 if it's between valid values. For example, at this time, we from the very beginning, we absolutely that we will replace it. So we will have wrong result. As a result, we should use from the backward. Okay. So how can we do it? First, we will use 3 pointers. P1 from the last valid element in num1 and last one. Here. P2 point to the last elements in num2. We have n equal 3. And point to the last position in num1 n plus n plus 1. So we will create a loop, and then we will loop. Assume that we will loop all this one, and we assume that we will compare one by one, and replace by this one, then we'll sort it. Okay. Yeah. Step 1. We will initialize 3 pointers. You can see this right here. Okay. What we will do here, we will create a loop while P2 equal to 0. So that means we will have something, we will on the loop with P dash. What does it mean? It's for move main placement pointer to left. Okay. So in this condition, we will have if P1 bigger or equal to 0 and n num1 P1 bigger than num2 P2. What will we do? So we will have num P1 equal to P1. Okay. Else, num1 P equal to num P2. B2 move to the left. Okay, so let me explain this one.